So hello, I'm Ayush Modi, and along with my team members Kaushal and Anish, we are giving a demonstration and the code walkthrough of the project for the course Foundations in AI Multi-Agent Systems. So for our project, we have developed an AI agent for the game called Four in a Row, which is a two-player game which consists of a 6x7 board, as you can see, where a player has to drop a disk in one of the given columns. And whichever player gets to four consecutive disks of his own selected color wins the game. And the four consecutive can be either horizontally, vertically, or diagonally. And we will explain that in our demonstration now. And we have for a project, we have developed an AI agent for this game, and it consists of varying difficulties ranging from easy, medium, and hard. And we have used the Minimax algorithm for developing the AI agent, along with implementing alpha beta pruning in this, which with which we have implemented the various difficulties. So now Kaushal will give a brief demonstration of the game.
So we have developed a website for this game and there are three levels, easy, medium, and hard. And for easy level, we have used min-max tree of the two with probability 50% and a random move with probability 50%. So let's play this game. Yeah, so uh, as you can see, I have clearly in this game and let's switch the difficulty to medium. So for the medium level, we have used min-max tree of that three and let's play a game. Okay, so clearly I can't play here. So I need to play here. So I need to play here. AI wins because it has a diagonal four in a row disk. Yeah. And let's play the game with hard difficulty. Okay, let's play here to prevent. Let's place one disk here. Okay, so we have to play it here. And let's play one more. So it prevents us. Okay, so let's prevent this thing. Let's place one more here. Okay, so we can't play here. We have to play. Yeah, as you can see, AI wins even after me playing optimally. Yeah, so this is the hard level.
So now we'll do a walkthrough of our four in a row game code. So for front end, we have simply used HTML and CSS. For the back end, we have used Flask library, which is built in Python. So our code contains some helper functions which are required for the game to function, and our code is written in app.py. So when we will run app.py, it will create a web host which will run a website on it. So I'll go through each of the files just once. And this is our app.py. We have given number one to the player and number two to AI. Create board is a function in helper function which helps to create a board. Then we have defined a function for the player to move, which just takes the input from the player and depicts it on the board. Then we have an AI move, and for that we have three difficulties: easy, medium, difficult. So if we have the user if haven't choose any difficulty, the base difficulty is easy. And then it checks if it's a valid location, then it drops the disk on that column, and that response is also sent to the website and it shows on the website. And this is the user for setting difficulty. If the user wants to change their difficulty, they can set it to medium or hard. And this is the restart function which restarts the game. So I'll go through this. This is the template which contains our front end code, and the static files contain the CSS which is used to design the website. So our helper function. So first is the positions.py. As I discussed earlier in the app.py, it creates a create board, drop, it creates a blank board. Drop piece means it drops the disk into that column. Get open row is the we get the next open row in that column. Is valid location is the function which tells us if that column we can go it to not. Or get valid locations gets all the columns which we can fill with the disks. So our code mostly contains of the core, the crux of our code is the min-max function. So the min-max, this is the min-max function. We have also implemented alpha beta pruning for code optimization, and we have checked it. So alpha beta pruning is very optimized, and it helps us a lot more than just min-max function. So for minmax, we get all the valid locations, and is terminal is as discussed above. It tells that if the game has if the game is over or not, or if in the draw condition the if all the valid locations are zero, then if it tells that the game has over. It so the base condition is that if depth is zero or the game we cannot move further, it if it's a winning move for our AI agent, then it gives us a reward of 10 raised to 5. And if it's not the winning move, if the player moves, then it gives a negative reward. And if it's hard, the difficulty medium is hard, then we choose hard heuristics to perform our scoring function. And if it's easy or medium, we use a simple score position. So what are hard heuristics and score position? So score position is the basic scoring function of our min max algorithm. And when it reaches to the last node, the depth of the tree, it uses a scoring function. And the scoring function uses an evaluate window function, which is just some basic heuristics that if I win, I'll get 100 score. If I get continuous 3, I'll get +5. If I get 2, then I'll get +2. And if the opposition winner is getting a win condition, then I'll put my score as -4. So this creates some basic heuristics for easy and medium functions. And now the hard heuristics. So this is our hard heuristic. So what for hard medium, what we have done is that first we have blocked the move. So our first priority should be that we should block the move of the opponent. If he wins, then the game is over. So our first priority should be that. Second is prioritizing and controlling the centers. So if we are able to control the centers, then we can get more score, as centers are more prone to get filled, and the edge ones are not will not be helping much to us. And the third ones is that we prevent any opponent's future threat. So if our opponent get continuous 3 in a row, it is possible that he can get continuous 4 in a row, or it can get continuous 4 in a row next time. So we also have heuristics that it also prevents 3 in a row continuous for the opponent user. So this is the hard heuristics if the opponent chooses hard difficulty level. So and yeah, so coming to our min max function. So if it so the min max function has a parameter alpha, beta. Alpha is the maximum value which a user can get above the tree, and beta is the value which and beta is the value which the minimizing play maximum value that the minimizing player can get below the tree. And we have the maximizing player. If it's true, then we have that. If it's false, it's the minimizing player and the level. So if we have maximizing player, then we implement the code for min max function. We firstly we choose a random value if in the valid locations, if and then what we do is we use a recursive function for min max, and then we give a chance to the minimizing agent. And for alpha beta pruning, we have given that alpha is the maximum value of alpha and the value that we get from below recursive functions. And we know that if alpha is greater than beta, means that if the maximum value that player can get above the tree is greater than the minimum value that the opposing player can get below the tree, so we cannot do better than that, so we just break the tree. So this optimizes a lot. And it's almost same for the minimizing player. Just we start with infinity, and the scoring function is just the opposite for the minimizing player. And as discussed above, this is the easy AI move, which means that it takes a random choice, and medium is the one which takes minimax algo of depth 3. The hard AI takes the min-max depth of 5, and it also contains hard heuristics. And the mixed easy AI move is that it randomly it has a random 50% chance of choosing a random move, or it chooses from depth to min max tree. So yeah, this is our basic code. Thank you.